Hello and welcome back to Ganesh Institute. So in this section, we are taking up Cauchy's integral formula to go ahead with complex analysis. Okay, so let's begin. Cauchy's theorem. What does it state? Do you remember we have already talked about analytic function, harmonic function, and harmonic conjugate function, right? I'm hoping that you have already watched those videos. So if not, then have a look. Cauchy's theorem states that let's say if a function is there, fz, we are reading it in complex analysis, so z is the normal connotation. So fz is a function and let's assume that it is analytic. Okay, that means it is continuous, differentiable, and what else has to be there to be analytic? Cauchy-Riemann's equation have to be satisfied, right? So this is analytic function. And when we talk about a circle, a region of convergence in complex analysis, we have this sort of form where R is called radius of convergence, Z0 is your center, and this is the whole region of convergence. Okay, so if it is, let's say, analytic function, and where is it expanding? The whole contour of the closed curve. Let's say this is C, closed curve. It has a contour. We have line integral and surface integral. We call it as contour. Okay, contour integral. So we have a region all over the circle. Then fz dz will be 0. So it can be asked in your MCQs or statement based true false question that if fz is analytic, then what will be the contour of fz? That too for the closed curve, inside and on, not outside. Here it will be 0. Okay, so can we say that fz is analytic? That means there is no singularity, it is defined everywhere. So if there is no singularity, that means the function is entire, and for that fz dz contour integral is 0. So this can also be rephrased into this form. Okay, if I ask you, tell me the contour integral of z raised to power n dz. Now z raised to power n is a polynomial of n degree, correct? And we know polynomial is continuous, differentiable, and analytic everywhere. So of course it will give us 0. Now let's talk about the main thing which the title is about, Cauchy's integral formula. So if we have to calculate, let's say there is a function again, fz, analytic function, and it is expanded inside and on the contour of a closed curve C. Okay, now I have assumed that there is a point A, let's say, inside it. Okay, inside the region. Then if I have to find out the value of function at that point, that will be equal to 1 by 2 pi iota, 1 upon 2 pi iota contour integral of fz dz divided by z minus a. Okay, z minus a is that point. This is the Cauchy's integral formula. Let's see how can we apply in the question this form. Okay, so let's say a question is given to you. There are two ways of solving it. Either you can use partial integrals, partial fraction method, or you can use adjustment of poles. At the moment I'm telling you how you can use it through adjustment of poles. Okay, let's say a question is given that evaluate the integral, find out the integral of sine pi z square plus cos pi z square divided by z minus 4 z minus 2 dz, where the circle is defined as z modulus 3. Okay, now in denominator just check out what is being given to us. These are the poles of the region of convergence. So we have z minus 4. If we put it as 0, z will be 4. Let's say 1, 2, 3, 4. It will come here, somewhere here, right? On the right hand side. Now if z minus 2 equals 0, z will be 2. So it will come somewhat here, 1, 2, 3, 4. Here. So tell me which of these poles lie inside the contour or on the contour of the region which is given to us. The region which is given to us is, can I write it in this form, z minus 0 equals 3. It means radius is 3, center is 0. So this z is equal to 4 lies outside the contour of the integral. So we will be having 0 as the answer for this, because Cauchy's integral formula is defined for inside and on the contour of the region, correct, of the curve. Z is equal to 2 is okay. So let's begin. How can we find out the integral using Cauchy's integral formula? So just now I told you the formula that if you have to find out the value of function at a, then the formula is 1 by 2 pi iota contour integral of fz dz upon z minus a, right? So try to write fz dz. See, we have fz dz upon z minus a, but we have 2z minus a here, right? So convert them into sort of this form. Can I divide this region of convergence into two parts? One, let's say C1, where my fz will be this only, but what I'm doing here, I'm writing z minus 4 divided by z minus 2. Can I write it this way? Because actually this will give you this form only, question form only. Because see, it has 1 in denominator, it will go in reciprocal and give you this question's original form only. Similarly, for another region, I am dz, don't forget to put dz here. I am now taking up another pole. Instead of z minus 4, I am taking another pole, z minus 2, and I am taking z minus 4 in denominator. Again, it will give you this form only. It is something like splitting the limits, correct? Now see it this way. This is your fz. This is z minus a, and this is dz. Similarly, this is fz. In Cauchy's integral formula, just apply this analogy. This is fz, this is z minus a dz. So for this contour integral, can I take this 2 pi iota onto the left hand side? Yes or no? And it will give you the answer of this particular integral. Yes or no? Alright then. So tell me, what is z minus a? What is a here? A is 2. What is z minus a here? 4. So a is 4. And we have already talked about that for 4, it is lying outside the region of convergence. So its integral will be 0. Correct? So what we are supposed to solve now? Only the C1 part. Correct? Because it is lying inside the region of convergence. So I have limit fz dz upon z minus a, this bit. So it will be 2 pi iota into Fa. What is A here? 2. That means 2 pi iota F2. Yes or no? Just simply in Fz substitute Z as 2. In this Fz substitute Z as 2 and you will get your answer. That means it will be 2 pi iota Fz for C1 is sine pi Z square plus cos pi Z square divided by Z minus 4. This is only Fz has to be taken. Okay, only function has to be taken and instead of Z you have to put A as 2. This is the question. This is how we can use Cauchy's integral formula. Okay, so now if you substitute, let me space out. Okay, now if I substitute Z as 2 here, what will you get? Tell me. It will be 2 pi iota sine pi Z square. Z square means 2 square. So 4 pi plus cos pi Z square. That means 4 pi again divided by 2 minus 4. That is minus 2. Okay. I have simply put down the value of Z as 2 because my A is 2. So this is the value of integral. 2 gets cancelled. We have minus pi I. What is here? You know n pi. Sine in terms of n pi give you 0 always. And cos, if it is even multiple, 2 pi, 4 pi, 6 pi, it will give you plus 1. And if it is cos 1 pi, 3 pi, 5 pi, odd integral, that will give you minus 1. So here 1. Correct? Yes or no? So what is left? Minus pi iota. This is your answer. I'm hoping that you have understood. And if so, then don't forget to like, share and subscribe our channel. Till my next video, take care of yourself. Bye-bye.